Welcome to section 10.2. For this one, there are parts that we'll be covering in class here. The basic idea here is with section 10.2 is we need a more general way of finding power series for functions because we're not always going to be able to use our basic power series of 1 over 1 minus x or derivatives or integrals to find all of the series for functions that we need. And so the Taylor series is a method of finding these without resorting to 1 over 1 minus x. Um, in class, I'm going to show you where this comes from to help you have an easier time remembering what this is doing. But the basic idea is that if I have a function and I want to change it into a power series uh, based centered on x equals a, I would do my first term would be whatever f of a is. The second term is f prime of a times x minus a. The third term is f double prime of a over 2 factorial times x minus a squared. Then my third term would be f triple prime of a over 3 factorial times x minus a cubed. And then kind of how each term is found, it's that so if it's that place's derivative of the function with a plugged in over that place factorial times x minus a raised to that place's power. So if I needed the 10th term, it'd be the 10th derivative of a over 10 factorial times x minus a to the 10th. And then kind of here is using sigma notation. For these, a lot of times we're not going to use the infinite series. We're going to use a partial sum of it. And when we do that, it's called a Taylor polynomial because it does stop somewhere. It's not infinite. So Taylor polynomial for order n means I go from 0 up to whatever n is. So if I wanted a fourth order, I'd have a 0, which would be the first term, n would be 1, which would be for the first derivative, n is 2 for the second derivative, 3 for the third derivative, and then 4 for the fourth derivative, and I'd stop there. Uh, a special type of Taylor series is if we center it at 0, which is a very common type of Taylor series. It gets a special name. It's called a Maclaurin series sometimes. But if it's centered at 0, it's called Taylor or Maclaurin. Centered anywhere else, we just call it Taylor. Just for reference, page 495 in your textbook has a list of very common Maclaurin series. And then just as a side note, we'll deal with this later, but if intervals of convergence overlap for the Taylor series, we can add them, subtract them, or multiply them by a constant. We're not going to worry too much about intervals of convergence in this section. It actually will be sections 4 and 5 that we focus on those. So this is just kind of an introduction to the Taylor series itself. The next video will go over some examples of actually using Taylor series to generate a power series for a function.